Hello, and today we're going to be creating a platform game. I'm actually giving you a script to start off with called Platform Starts, and it has some basic things in here such as a player. It's already added to the stage, and it's in a stop position, and it has all your keyboard events. And it has an event listener called check direction that is checking the direction. We have those booleans set up again, the left, right, and the up. These are all things that we've already done twice now, so I did not want to have to go through all of these functions again. You guys already know how to do these, so we are going to start off with this code, and we're just going to add on to it the new information that's going to act a little bit different than some of the code that we've done before. If we look at our compiler new, it may also, I think it's the one that's called compiler CS3, and we look at the library in there. We've used our boy before, and if we look at the edit mode for the boy, what you'll notice is that his registration mark is at the bottom. Now if we look at the items that we're going to be using for our platform, the rock, the square, and the square 2, what you'll notice about these pieces that we're going to be using for our platform is that the registration mark is in the upper left. This way, when we do a check to see, to make the boy match his Y value with the Y value of our registration mark, you'll see that it'll just line up to wherever the top of the object is. So that will be very convenient. And we have it on the left side so that we can line this up the way that we did our enemies. If you remember from when we were creating our enemies, we had our registration mark also up here in the upper left corner. So that way we had that calculation that would, when it would place the next enemy, it would go ahead and calculate the width of that enemy. And then we said plus 10 more pixels to place the next enemy 10 more pixels beyond it. Of course, and with the registration point being still in the upper left corner, it's the width plus 10. What we're going to be doing this time is basically the same thing, except it's just not, we're not going to add that 10 pixels. It'll be just whatever the width is of the platform. So if it's in the upper left corner, can't draw with paint very well. Then when we go to draw to place our next platform, no matter, we'll just look at the width of the next platform, whatever that width is, then it will calculate where the next platform wants to be. So when it's going to place the next platform, it'll look at this current piece, and then it will go ahead and place it at the end of the last piece that was placed based on its registration point. So I just have a difficulty drawing in paint here. But you get the general picture of what we're trying to do, I think. And if you remember from the add enemy script, we're just doing basically the same thing. So we have our 3 different platforms here. You can see that they are all different shapes as well, and you can see that our rock shape is all curved. So this is what we were talking about. We're going to be also doing the hit test point like we did in the last class, so that way our boy can be looking per pixel whether or not he's hitting this accurately. So let's go ahead and go to our platform start. And the first thing that we want to do is we actually want to make all of our platforms. Okay, so we want to make a platform by taking these three different pieces of the platform, the rock, the square, and the square 2, and randomly placing them in order. And let's bring on six pieces, and those 6 pieces, they can be 6 pieces of any of these 3. Okay, so let's first start off by just bringing on 6 of one of the pieces. Let's start by just getting one of these types on, creating a platform with just one of these, such as the square. We'll start with something easy. So when we want to bring on multiples of something, how do we do that? And I know you're all saying, well, we use a for loop when we want to bring on multiples of things, like the pedal and things like that. And you're right, that's exactly what we want to do. So for, we'll use our good old var I, that'll be an int. And we'll start at 0 because we're going to need to put this into an array. I less than 0, increment it. Okay, and open curly bracket, closing curly bracket. Okay, and now we want to go ahead and we want to create our first, we're going to create a variable for our platform. And then we can, actually we're not going to data type our variable this time. Normally we do. And that is because we are eventually going to, in order to do the randomized selection, we actually can't set a data type in this case, because otherwise Flash will get confused. To just make a note about data typing, the reason that we data type in Flash is more for debugging purposes. It helps Flash keep track of whether or not items match up, because when you're coding, your data types do need to match up for things to work. And if you specify a data type, if things aren't working, and you specify that this is supposed to be a data type, then it'll be easier for Flash to find that problem and say, oh, well, you have a type mismatch, and that's why this isn't working. So that's why we normally do data type. It helps in the debugging process, helps Flash tell you that you're trying to mix types and tell you that you're doing something wrong. And so in this case, we are going to have to take that chance and not put a data type in there. I'm going to just do, and we're going to just for right now, we're going to say equals new, and let's just use the square to start off with. Let's bring on a square from our library, and of course we want to add it to the stage. Platform. Oops. And then, okay, so we've added it to the stage. Now we need to position the platform. And so now when we are working with the enemies, the add enemy text, if you remember, we had a variable that kept track of the X position of the enemy. So that way when we were placing the enemy, it had an original X position that was assigned to the variable, and then every time the loop went around, it would recalculate that X value, so that way when the second enemy was brought on, it was recalculated, and the second enemy would be placed at a new x value. Well, that's what we need to do here as well. So let's go to the top and let's declare a private variable that we'll just call platform x, and this is going to be a number variable because we know that it potentially could get down into decimal numbers for this. Let's assign it to have an initial value of 0. And so that way it starts all the way over on the left. The first platform starts all the way over on the left. Okay, so now we have created our platform X. So now we can go ahead and use that variable to place our platform. So we'll say the platform, and the X position is going to be platform X, which of course the first time through is going to be 0. Okay, so now that we have placed the platform, now we also need to place the Y value of the platform. So let's go ahead and write that, platform.y. Now, what we want to look at in this case is we'll just start with, we'll have the platform. Normally when we place things, we want it to be near the bottom, so we look at it in terms of the stage height, because that is always at the bottom. And now we want, though of course we don't want our platform all the way off the stage, because if you remember, the registration point is up here in the upper left. So if we set this registration point to be the stage height, it would be all the way off the stage, and that isn't really what we want. So what could we calculate with the stage height to make it move up the height of the platform? And I know that you're saying, why, if we actually subtract the height of this platform from the bottom, from the stage, that stage height, then that would raise it up just enough so that the bottom of this platform was at the bottom of the stage, but we would see the full height of that platform. And that is correct. So we'll start with looking at the value for the stage, that stage height. Then we'll go ahead and we'll take away the platform height, and that will raise it up. Now, when we are placing our platforms on the stage, I mean, this would be fine if we wanted it to be just straight across, you know, whatever the height happened to be of that particular platform, that would be fine. But a lot of platform games aren't necessarily even the whole way across when they create the platforms. A lot of times the platforms will be a little bit higher or a little bit lower. So let's add a little bit of variation again by subtracting further. Let's subtract a number a little bit more from this, but we want it to be varied. And so how do we make things varied? Why, I know you're all saying, well, we use a random number. Yes, that is correct. So we're just going to calculate a random number here, lowercase r, please. We're just going to do a math random, and then we're going to times it times whatever, however much variance you want to give it. So if we want it to vary by, like, 60 pixels, then we'll put 60. If we want it to, vary by 100 pixels, you put 100. So that means that we could be subtracting from as little as 1 pixel, which would just make the platform move up just 1. Or we could be, taking away all the way almost 60. And, like I said, so it's how much of a variance you want. I'm actually only going to subtract 60, have it top out at 60, because remember, I mean, your player does have to be able to jump up. If it does choose the maximum amount, the player still does have to somehow manage to get up to that top platform, and if you make it too high, then they might not be able to make it. So I'm going to stick with 60. Okay, now the next thing that we need to do is, oftentimes when we're using loops, we have to keep track of whatever we're putting into the loop. And that is definitely the case with the platforms. We do need to keep track of the information associated with these platforms. We need to talk to all of these pieces that are making up our platform, because we're going to be moving our platform around relative to the boy. So if we need to keep track of these pieces that are making up our platform, what do we need to do? We need an array, don't we? Yes, we need an array. So let's go ahead and let's make an array that we're going to call platform array. Let's go ahead and declare it up at the top. Platform array, to keep track of our arrays, our pieces of the platform. This is an array object, and let's just go ahead and start our new array. Okay, so that just opens up our array. It's like having a new, like doing file new. Okay, so we have our variable called platform array, so we can, it's a class variable, and we actually started the new array. So that way, when we are down here in our for loop, that we can go ahead and add our pieces to the platform array. So we're going to talk to the platform array, and we will use our push command and put the platform, the current platform, into the array. Okay, so now, so we've created the platform based off the square. We've added to the stage. We have given it in X position based off of our variable platform X, and we've set the Y value, and it's based off of the bottom of the stage minus the height of the platform, and then a random number up to 60. Okay, so that will set our platform, but now we need to, before this is great for one of the platforms, but remember we have this platform X. When we need this to be recalculated, so that each time through the loop this platform X can change. So what we need to do is we're going to go ahead, and before we exit this loop, we're going to talk to platform X, and we're going to say that we want it to be equal to the width of the current platform. So it's just going to go ahead and look at what the current width of the platform is. And then and then we have to also look at what its current x position is so that we can add the width to its current x position to come up with our new x position for when we come back around. So we're going to look at the width, and we're going to go ahead and look at what its current x position is. Okay, so now we've made the recalculation, and so now the width, so now when it goes looping through, it will be able to move them, place the platforms going across so that they're not overlapping one another. Okay, our loop here, sorry about that. Right now it won't go very far because I said I less than 0, and we're starting with 0. That's no good. We have to, in our loop, we have to choose how many pieces of our platform do we want. And we could, if you wanted to, just so that you would have a quick and easy variable to adjust at the top of your script, you could in fact create a variable. We have the platform x variable up here. You could also create a private variable that will call number plats. How about? And this can be an integer because these are just going to be whole numbers. And this is where we'll just set the value right here at the top, and we'll start with just having six pieces to make up our platform. Okay. And the reason that the reason it's really nice to put these variables up at the top is so that way in your script, when you might have to be choosing how many times you go through these loops. We're going to be actually making several loops in this script that are referring to talking to our pieces in our platform. So this is being able to create a variable for these pieces is really nice, because then as we write our scripts and we're just using this variable, if later on you decide, like, okay, now I want 10 pieces in my platform, or I want 2 pieces in my platform, make it really short, it's very easy to just change this number here at the top and have it affect everything in the script. That's a lot nicer way of doing it. So instead of using in our for loop 0, we'll go ahead and use our number plats variable. And so that will, like I said, that will be much easier later on if we keep using this variable to go back and be able to change this. Okay. Alright, so let's go ahead and I want you to actually, before you just go ahead and save this out, what I want you to do is I want you to rename this to platform, and you have to rename it in the class and in the constructor. So the class and the constructor, we're just going to rename to just platform, and then we'll go ahead and we'll save it out. Okay. And so go ahead and save that out. Okay, so make sure that your name of your file matches your class name and your constructor name just perfectly. So go ahead and save that out. I've already saved mine. Let's go ahead and check and see what we have so far. We have the compiler, so go back to your compiler. Make sure that you place in your properties in your compiler pointing to the platform. Make sure that your compiler is saved into the same folder as your platform script. Okay, and so we have our platform here, and now you're probably only going to be seeing one. There are others there. There should be others there. These are fairly, these square ones are fairly long. Now we don't see our boy. If you remember, our boy is, the registration point is on the bottom, and we never set the Y value for our boy. So as you can see, he was off screen. Remember that the default registration point, the default X and Y value for placing an object on the stage is 0, 0. We did go ahead, there was already placed in there where we were looking at half the stage width for the boy. We set the X value, but we did not set the Y value. Let's go ahead and set the Y value of the player. So, but let's do this based on the height of the platform, of the first platform. Okay, so we know that our boy player is, our boy library item has a variable name of player, so we're talking to player. We're talking to the Y value, and so what we want to do is we want to set it to the same Y position of the first platform. Remember that on our platforms, the registration point is at the top of the platform. So if we place them at the exact same Y, then it will essentially put the bottom of the boy at the top of the platform. So it'll make him look like he's standing on top of it. Okay, so how do we talk to the first platform? Well, if you remember, the platforms have been placed in an array. So we can talk, we want to first talk to the platform array, and then remember, these platforms have all the information for the platforms have been placed in a position in the array. So remember how arrays work. There's like position 1, or there's position 0, there's position 0, 1, then there's position 2, and so on and so forth. So position 3, and in these positions we've placed all the information for the platform, for each platform that was created. Yeah, having a tough time with this paint here. Okay, so there's a platform in there. There's a platform in position 1. And each one is going to have, different attributes to it, different information stored with it. So we want to look at the information of the platform in the first position of the platform. But when I say first position of the platform array, you know that arrays start with the 0 position. So the 0 position is what we want to look at. So we talk to the platform array and we look at the 0 position, and we are looking for the Y value. So whatever the platform is at the 0 position, and we're looking for the Y information, it's going to read that property and then give it to the player's Y position. So now when we save this and we compile it, now our boy is on top of the platform, and as you can see, he moves back and forth. Our keys are working, so you can go ahead and use your keys. We don't have the up going yet, but that's okay. We're going to be working on that. It's mostly the left and right that are going to be working so far. Okay, and just, you know, basically it's just playing that movie clip, so you can see that the actual platforms themselves are not moving yet. Okay, so now now what we need to do is we need to start moving these platforms relative to the boy. Actually, let me just run that again. As you can see from your key controls, when you push the right, the movie clip starts playing so that his legs are moving back and forth. He is not moving. When we go to the left, he flips over. Basically the movie clip is playing and he is not moving. When you're doing a platform game, it's not the boy that wants to move, because if he started to move, all of a sudden he'd be off the screen, and that's not what you want. What we need to do is we need to move the environment that the boy is standing in. We need to move the environment relative to the boy, either to the left when he's moving right, or we need to move the environment to the right when he's moving left. Okay, so it might take you a minute, when you're thinking about these things, you might have to, think a little bit about, okay, I move, think about it twice as hard, because, yeah, it's going to be doing opposite of what you think it wants to do. Okay, so let's start scripting these platforms to move. Okay, so just like what we were doing on Monday with our maze game, where we were using our booleans and the square was moving around depending on if the left was triggered or the right was triggered. We're going to do the exact same thing today, but instead of moving, like I said, the player, what we want to do is we want to move all of the platforms or the environment relative to the boy. So if you remember from Monday, we were, just in the left and the right, we were, like I said, we were moving that player around, or that square around, and affecting its X and Y position. Okay, in this case, like I said, we want to affect the platform pieces, all of the pieces, X position. We want to tell all of the platform pieces, tell all of their X positions to move a certain amount of pixels to the left, well, not to the boy's left. So the boy is going to be trying to appear to be moving left. So what we were saying before is that let's get out good old paint here. So when the boy, here's my boy. Here's the boy, and we'll say that he's, oopsie, and he's gonna start, he's gonna go this direction. He wants to, when he's moving, sorry, we're starting with the left. Let me change his eyes around then. That means when he's moving to the left, when he wants to, in theory, move to the left, that means that all of the platforms here need to move to the right. So he's, in theory, moving to the left. All the platforms need to move to the right. Platforms right. Okay, so if we want to talk to all of those pieces that make up our platform, how are we going to do that? Well, if you remember when we were talking, we wanted to talk to all the enemies in our add enemy class, or if we wanted to talk to all of the bullets in our bullet array in the add enemy class, we were using a loop, and we were using a loop to go through each position in the array and amend the whatever we needed. In the bullets, we needed to amend the Y values. But in this case, what we need to do is we need to amend all of the X values. Okay, so we're going to have our handy dandy loop for create our variable again. Let's actually use use L for our variable name in this case. For I'm saying for left, and it's going to be an int again. And we are dealing with an array, so we need to start at 0. And we're going to say L, and then now we're dealing with the number of platforms. Of course, we could also use the expression of platform array dot length. We could also use that expression as well. Actually, you know what? We should probably use that expression, platform array dot length. Have you get used to that? That's actually a really good expression. And then increment RL. So that's L there. Don't get that confused with 1 or I. That's L for left. Closing parentheses, opening curly brackets. Okay, and now we just need to talk to our platform arrays, and so we talk to platform array, platform, not plat, platform array at the L position, talk to the X property, and then we want to amend the X position, so we're going to do a plus equals, and we want to move these right. So when we want to move items right, what kind of number do we add? A positive number. So let's move it 10 pixels relative to where it's at. Now we're going to do the exact same thing for the right. The exact same thing, except let's just change our variables from L to R for right, because we are in the same function. Notice we have not left this check direction function. That means we can only use a variable name once. This is a local variable. Variable L is a local variable. We can't reuse L. So that's why for creating our loop for the right, we're going to use a variable name of R for our loop for right. And we need to increment our R value as well. And then we want to check for our platform array for R, the R position. And now when we are going right, when the boy, let me make a comment here. When boy, or player, since that's our variable name, player is going right, platforms want to go left. So that means this needs to be a negative 10. Yes? Negative 10. Now let me make a little comment up next to the left as well. Okay, when player is going left, platforms want to go right. Okay, let's see what we have so far. Okay, there we go. Now the boy is moving right along, and as you can see, he's walking through the platforms. Not exactly what we want, but we see our platforms now too. If we keep going, it'll go through all 6 platforms. You can see that they're being placed at different heights, varying heights. So far they're not very far off from each other, but they are varying heights. Some are higher than others. We don't have any that are too tall. And now we're at the end, and he keeps going. Okay, so we'll add more to that. Okay, so now we need to check. We don't want the boy to be walking through the platforms. We want it so that when he comes to the edge of the platform, the detection is made and that he stops, and that we will then have to jump up or do something so that he can get up to the next platform. So here in our check direction, one of the things that we're going to have to do, besides checking whether or not these booleans are true or not, is that we also are going to need to check to see which platform the boy is currently on. We need to know what platform the boy is on so that we can check to see whether or not he is heading the next platform either to the left or to the right. So we need to go ahead and run a for loop that runs through the array and checks to see which platform is the boy, piece of the platform is the boy currently touching. He needs to constantly be checking this. That's why it's on the check direction function. Okay, so we'll go ahead and since this is going to be the first loop, I am going to go ahead and use our I variable, be an int, and we're going to be using an array, so we'll start with 0, and then we will say I less than, let's use that platform array dot length term, and we need to increment our I value. Okay, and now we need to go through our array and we need to basically have a hit detection to see whether or not what platform the boy is currently on. Okay, so we also are going to need a variable that we can call which platform. So we can say, you know, define which platform he's currently on. So let's go ahead and create a class function up at the top. Just because this variable we're going to be changing a lot, and whenever you have a variable that's going to be changing a lot, it's best just go ahead and declare it up at the top. So I'm going to create a variable that I'm say call which platform, and that can be an int. And that's just we're going to use that to define which platform the boy is currently on, the player is currently on. So we're declaring that here at the top because it's going to be constantly changing. And then in our check direction function, we have our for loop that's going to run through the array, and we're going to do our hit test point. So we're going to be looking at whatever the current platform, we're going to look at the platform array, and we're going to look at the current position, I, hit test point, against the player's X position. Remember, you have to choose an X and Y, so we're seeing if that registration point of the boy is hitting a platform. And we're just going to take the straight player X and Y position, and we're going to set the shape flag to true, so that way any of the pixels on whatever platform he currently is on can be detected. And oh, I almost forgot, there's two closing parentheses at the end. And if this is true, and pretty much all the time, most of the time it will be true, we are going to be defining the which platform variable to be whatever the I value is at that time. So whenever this if statement is true, so if the boy, of course the boy starts off and he's going to be initially starting off on the 0 position. The platform that he's going to be resting upon is the 0 position, the 0 piece in our platform array, because that's what we defaulted to. It starts there. And so when this first starts up, the part that will be true in this array, as it's running through the array, will be the 0 position. It'll run through the whole array. But the only one where this is going to be true is the one that he's actually intersecting. Okay, so like it's going to run through the array. It's going to run through the first position, the second position, third, first, fourth, fifth, but you know, he's not going to be standing on the piece of the platform at the first position. So therefore this line will not be true for the first position. It's only going to be true for that 0 position, and that's why platform, and so the platform will be set to 0. So we need to do this check so that way we can, over here in our left and our right, we can create another new variable that we can call next platform, and that we can use to detect whether or not at this position he relative to what the current platform is, the which platform variable, if whether or not he's hitting that next platform. So let's go ahead and create another variable up here at the top that we will call next platform. And now it's going to be an int. And when we have this private variable next platform, now we can go ahead and we can use this here in the left, and we'll just say that next platform is going to be equal to which platform. So we want to look and see, okay, which platform are we currently on? Okay, so when we're going, when the boy is, if you remember, when the boy is going to the left, that means we want to see what platform is prior to the current platform. So we can say whatever platform you're currently at, if we take away 1, that will give us the next platform over to the left. Okay, and then for the right, we can say that the next platform is equal to whatever the current platform is, which platform, and then we can add 1, because when we're moving to the right, the platform will be moving off to the left, and so, you know, the 0, the first, the platform piece in the first position would be coming towards the boy, and so of course that would be, you know, 1. So we'd be wanting to detect whether or not he was hitting, you know, a platform name, you know, in the first position. And that's what we do want to check against. Now what we need to do is just exactly what we were doing on Monday. We have to set up one of those points, one of those hit test points, like we were doing on Monday on the boy, to see whether or not he's hitting a piece of the next platform. So if, and then we'll talk to the platform array, and what we want to check to see is, you know, is he hitting the next piece? Is he hitting next platform? That position in the platform array. So hit test point, and we're choosing a point on the boy. Now here's where we want to do what we were doing on Monday, where we don't want to necessarily test, you know, if we just choose the player X and the player Y for our XY values, remember, that's at the bottom of the boy. That's in the bottom of the boy. And so that's not going to really be very useful, because, you know, that'll be very hard for it to, or he'll walk halfway through the platform before that detection hits, you know, possibly registers. So what we need to do is we need to create a little detection point over on the left side of the boy, because this is for him moving left. And then I like, we could have just put it in the bottom left corner if we wanted to. I'm actually going to put it just a little bit up, because remember, our platforms are of varying heights. So I'm actually going to move it up about 10 pixels. So we know we want the detection point to be over on the left, so we can talk to the player. So we're going to look at the player X position, and remember it's on the bottom. It's actually kind of in the middle of the boy. It's actually in the middle of the boy. So what we can do is, when we want it on the left, we subtract. And how much are we going to subtract? Well, just like what we were doing on Monday, so half the width. We'll just say player dot width divided by 2. We'll just subtract half the width. That will move that over to the left. And then we'll go ahead and we'll look at the Y value, which remember is all the way at the bottom. It's already all the way at the bottom. The registration point is already at the bottom. So you look at the Y value, and I'm just going to move this. I'm not going to move this all the way. I'm not going to move this halfway up the boy. I'm just going to go ahead and move this like 10 pixels up. So I'm going to say the Y position then minus 10. So I mean, you could have that detection further up from the bottom. You could have it halfway up from the bottom if you so desired. But I'm just going to put it 10 pixels up. And then we need to do that shape flag, so we need to have set that to true. Double closing parentheses, opening curly bracket, closing curly bracket. And if he runs into it, what we want it to do, exactly what we did on Monday, we want it basically to move in the opposite direction, so it gives the appearance that it's not moving at all. We're going to basically negate whatever we're doing before this if statement. Zero it out. So it appears to be not moving at all. And now we're going to do the exact same thing here on the right. So in our for loop, after we tell we're telling the platforms to move to the left to make a player appear to be moving on the right, then we are going to set up now a detection point. If our player is supposed to be moving to the right, then what direction do we want our detection point? We want it on the right side of the boy. So in order to make that detection point on the right side of the boy, we want to, how do we want to set up our, what do we want to set up our X value to be? Well, just like what we were doing before, look at the X position, and instead of minus, that just becomes a plus. That moves it over to the right. Our Y position is going to stay the same. I still want it to be about 10 pixels up from where it was from the bottom. And then we just need to basically negate what's going on over here. So I just need to, that's moving in a negative 10, I need to move this in a positive 10. Now we'll just zero out the whole thing and so that he won't move. Okay, so now setting up this position, this point on either side of the boy doesn't necessarily, make it perfect for all circumstances. So if we, have our boy here, and we set up a, position for him, a little dot for him, like right here on the right side and over here for when he's going left. If my platform for some reason is up here, it's not going to detected. Actually, that's what we want it to do. But you know, there's certain circumstances where the boy does need to be able to. It might not detect it correctly, and then, you know, he'll keep walking through it. So you might end up needing a couple of extra points on the boy to make sure that he catches all of the various platforms that you create, depending on the shapes and everything. So just like we were doing on Monday, you would just have multiple if statements. You just have an if statement for every single point that you needed to create. So maybe you had another one of these, but it was minus 30. So just, or, you know, maybe minus 40. You know, just make it further up. Maybe you had one that was all the way in the corner, so that way, you know, it was just the player Y, just to get it over in the corner. So you might, like I said, you might have a few of these for each the left and the right. I'm just going to use this one for right now, though. So let's see what we have so far. We'll run this. Okay, so now here comes the boy. Okay, well, all right, now this one, okay, we have a different circumstance because we have, okay, let's see if this one works. Okay, oh, no, see, he's too, yeah, that position, I think it's not quite, it's not quite hitting quite right. You also see that we have this error that showed up here, and that is because when I went to the left, it started saying that the platform, when it was at the 0 position, it was the platform was 0, and it was saying -1. That means that the next platform was equal to -1. Well, when you start trying to say that you're looking for a platform at -1, it doesn't like that. It doesn't like that because there's no such thing in array as a -1 position. So we need to do a little check before it goes into this for loop. And this is a case where the positioning of where you're coding does make a difference. So we set up our next platform variable here, but then we need to basically make a special case for this, where we say, okay, so but if the which platform equals, and this is where we're doing our comparison, so it can't be just one equals, it has to be 2 equals. If it equals 0, then what we want it to do is we want the next, we're going to say that we want the next platform, we're going to set that to, instead of equaling a -1, just go ahead and keep it equal to 0. Just to have next platform being equal to 0. That way it doesn't negate, that way it never goes to that negative value, which is a non-existent value for the platform. And when you're at the 0 platform and you try to go left, you're at the end of this particular platform anyways. So you know what, you're at the end of the game, you know, you're at the end of this particular side. So, you know, we're going to be setting up checks and everything to, you know, for if he goes off the end, that he starts to fall. You know, we don't want him stopping at the end of that platform. He needs to be able to walk off the cliff. So it's okay that this equals the same, because this is the end of this platform. And then the right, we need to also do this, a similar thing, so that it, once again, when it gets to that last platform, here it would be looking, it would be setting the next platform to a value of 6, which does not exist. Remember that the positioning is always 1 behind, so the last platform, even though we have 6 pieces in our platform, the last piece of our platform is actually at the 5th position of our array. So when we try to say, okay, look for, you know, a piece of array at position 6, it's going to say, like, I don't understand what you're saying. So we need to also, after we make this statement of next platform, we need to do another special case, essentially, where we say if which platform equals 5, which is going to be our last value. Actually, let's use our number. Let's actually be better about this. Let's use the number plats variable. That will make it, remember that we set that at the top. It'll be, that way we can set it, and once it'll take care of all this. If our number, if it equals our number plats minus 1, and it's minus 1 because remember our number of plats is the total number that we want, which is 6 in this case. But remember the positioning is, it has to be 1 below that. So 5. So if the, you know, platform, which platform equals essentially 5, what do we want it to do? Next platform, in this case, equals, we just want it to once again equal the last value, so number plats minus 1. Let's go ahead and also on our left, let's change our value over here. Oh no, that's the 0, so that's fine. So now, like I said, if we change our number of plats value at the top, you know, it would be affected the whole way through. These types of values we wouldn't have to be changing. Otherwise, if we just were using a hard number like 5, then we would have to go through, you know, if we changed, we want, oh, now we want 10 pieces in our platform. We'd have to go through and change this to 9, and what a big pain. What a big pain. So this variable comes in very handy. Comes in very handy. Okay, so let's let me see if I can adjust. Let me see if we can adjust. Well, here, I'll just run it again. Let's see if it catches that that 10 pixel. Okay. All right. Oh, we have a little wonkiness going on here. Okay. Let's see. Let's see what we have going on here. Oh, it just is. Looks like it's mostly happening at that first platform. The other ones seem, of course, I'm not hitting that. It's not hitting that. Next keeps on being too high in this case. All my platforms are too low and my boy is too high. We're going to be doing some changes to this so that when he comes to those platforms that are lower, that he ends up falling onto those platforms, and then we won't have to worry about them being too low, or and of course we're going to add the jumping so that if they're too high, you know, he can get to them. Okay, so we just have a little bit of wonkiness right now as far as when the it does look like actually on the first platform where the next platform was probably, it looks like it was hit. Okay. Okay, so we just need to, I made a slight mistake in the right. I forgot to change the, where it says L here when I was making my if statement because I was copying and pasting. I didn't change the where I'm moving the platform to go opposite the direction, minus 10. You can see my variable mismatch here. I need to make that the R position, platform R, and then moving the positive 10. So that's why those platforms were moving together. So just make sure that those variables are matching on the right. Should be all R variable, and for our left we're using the L variable in our loop, so just make sure those are all L's as where they need to be. Okay, so that should now make it so that he stops at the next platform. And let's see, you know, this one's starting off really tall, so I can almost guarantee that there's not going to be one that one's also very tall. Let's see, it keeps on randomly placing, having the first one be very high up automatically. Let's see if this one, okay, this one might be low enough. This is the next one, and there he is. He's stopping now at the next platform. And, you know, the one back is, there's nothing there. So, okay, so those should be working both in both directions. Okay, now, let's actually do, before we move on to the jumping, let's actually start mixing up our platform pieces. Right now we're just using the square. To create our platform. So when we are bringing on our new platform in our constructor, we're just always using that square. Let's mix it up so that way we're actually pulling from our library either the rock, the square, or the square too. So what we need to do is we actually need to create an array to pick from. We're going to create an array that's going to hold the name of those classes that are in our library. So we have created a platform array. And now let's also create a landscape array. Or you could call it pieces array, whatever you want to call it. I'm going to call it landscape array. And it's going to be a new array. And normally when we start our array, we have it be empty, and then we add things through the push command. In this case, what we're going to do is we're going to start our new array, and we're going to put elements in the array. And the elements that we're going to be putting in the array are our class names, the classes in our library. So in our library we have a rock, and we have a square, and we have a square too. Okay, so we're putting the names of the classes in our landscape array. So any of the pieces that you would want to make up your platform, you put their class names here. Okay, so then instead of down in our, when we are constructing our platform in our constructor, when we create each piece of the platform, instead of just particularly calling a class from our library, what we're going to instead, we're going to talk to our landscape array that is holding all of our various pieces. And then what we're going to do is we're going to choose a position. If I choose 0 position, that would automatically load in the rock, because that is in our first position of our array. Now we don't want to, once again, this isn't going to get us much further than when we just were typing in our square. So what we want to do is we want this to be a random choice selection. And And so we need a random number to be in here, but we only want it to be the length of this landscape array. So we're just going to create a little local variable that we'll call plat choice. And let me make sure that I haven't used that. No, I haven't used that. Okay. And this will be a int. And what we want this to be, a random number, math random. And we want it to be times the length of the landscape array. So we'll say landscape array dot length. Now the only problem with this is that this is going to yield a, potentially, remember this is a decimal number. This always is a decimal number. Then we times it times this length. It's going to yield us another decimal number. Now, you can never plug into, when you're talking to an array, along with being negative numbers, it can't be negative numbers or a number of a position that doesn't exist. It can't be a decimal number because there's no such thing as position 1.5 in an array. There's either position 1, position 0, position 2. They're always round numbers. So what we need to do is we need to chop off. We need to chop off any decimal numbers that are left behind. And so the way we're going to do that is we're going to do a math floor. We're going to floor this random number that was created. And all this does, the floor, is that it chops off the decimals. And let me just put a note. Floor chops off decimal numbers. Okay, and now that will give us a nice solid number. And so instead of placing in here a unique or just a number that it can only be used once, we can put in here that variable name of plat choice. So that way every single time through the loop a new plat choice is made, a new random number is chosen. Basically the landscape array is 3 items, so but it never reaches 3. It'll be 0, 1, or 2, and that number is calculated. And then when we are creating our new platform, that means that that number is being used to choose which position in our landscape array, based on up here, which item is going to be pulled in, and then added to the stage and pushed into our array. Okay, so now if we save this and look at our, you can see that we have now this square 2 was the first one that was selected, and then you can see that our regular square was what was selected second, and we have another square that was selected randomly, and then we have a square 2, and let's see if we ever get one of the rocks. We might not ever get a rock, because that's what is random. Oh, we did. We got a rock at the end. We got a rock. Okay, so now we have to be careful here. You know, it's okay. One of the things about our oddly shaped pieces here is that we have to do some detection as far as you know, when the boy won't necessarily run into himself on those flat pieces. It won't hit that -10 position. But on pieces such as the rock, it potentially could reach that position. So we need to change around. We need to change around our if statement here on our left and right, so that way the boy can check to see if it is hitting even a pixel on the current platform that it's at, on the which platform. So we have an if statement here for the next platform, and what we're going to do is we're going to add on to this if statement. We're going to say that if the boy hits the next platform, then it'll execute this. Then we're going to do two pipes, which is this is the key that is above the enter key on the keyboard. It's the backslash is when you're not shifting, it's the backslash. When you are shifting, it's what they call the pipe. It's one over from the closing bracket. So that's what that means right here. When we do two pipes, that means or. And that means or. And so we're going to say, okay, look to see if the boy's, this position that we set up, is hitting the next platform, or look at even the current platform array, or platform array, and say which platform, that means that this is the current one, dot hit test point. And we'll use the same coordinates that we used on this one. Use the exact same coordinates. So we're still going to use that where it's 10 pixels up. So now the boy is looking to see if this 10 pixels up from the bottom is hitting the next platform, or is it hitting a pixel on itself, which is only going to be the case on that rock where we have those curves coming up and around. Otherwise it won't be the case. And we're going to do the same thing on the right. So even if you want to copy this whole platform, not this curly bracket right there, but this whole hit test, and then we want to do two pipes again. And if you need to go over to the next line, you actually can. It should be okay. And instead of looking at the next platform, we're looking at the which platform, that just means if you're looking at your current platform as well, and looking to see if you're butting into any pixels. Because we don't really want him walking through those hills either. Okay, so now it's lucky, actually this works out nicely. Oh no, actually he has to fall down in order for this to work correctly. So he started off on the top of that hill, so it's going to be impossible for us until we get the jumping thing going. But basically this is set up now so that, if he ran into, if that 10 pixels up ran into a part on this rock, he would also stop. And because these other ones are flat, he would never, these ones he's not going to be, it's not going to trigger. It's only going to trigger on that rock.